Okay, this next section we're going to stop for a minute and do a little mini section on our special right triangle, so that way when we go back to the unit circle and I'll show you where our values come from, you'll have a little bit better idea of how we got to that point. So I'm going to pause it right now and draw some special right triangles for you. Okay, like I said, I apologize in advance for the drawing of these figures. So mostly pay attention to the degrees, the angles. So this is our special 45, 45, 90 triangle, and then we have our 30, 60, 90. And all of our trig values on the unit circle come from concepts based off of these right triangles. Now, these also fit the Pythagorean theorem, a squared plus b squared equals c squared. That's where these values come from. But our practice is going to be creating similar triangles to these using the above given information. So we're going to do some practice with that now. Okay, so take it for a minute, pause your video, and draw these figures real quick. We're just going to practice finding the missing sides using our properties of our similar triangles. Well, this is a 45-degree angle. That tells me that I'm working with these ratios, and I want ours to be similar. If this is a side of 1, and our particular one has a side of 5, what do you think, if this is 1 and this is 1, what do you think our side, this is a part we know side 5. What do we think this side's going to be? 5, exactly right, good. So because it's a 1-to-1 relationship, all right, and we multiplied this by 5, then this was multiplied by 5, so what do you think we do with this side? Multiply everything by 5. So basically we took this triangle and multiplied all of our sides by 5 and we scaled it. So this becomes 5 square root of 2. Okay, that's not too bad for us. But when we look at this one, for some reason, if you have any problems, this is the one that you struggle with. If I'm given this side 10, which is square root of 2, how could I get positive 10 there? What do you think they had to do? Divide by the square root of 2, right? So if I divide this by the square root of 2, then what do you do to all of the parts? Divide by the square root of 2. So if I have 10 divided by the square root of 2, now this takes us back to some algebra. If we have that, we're going to rationalize the denominator because we don't want a square root in the bottom, right? So you have times the square root of 2 over the square root of 2. This is called rationalizing the denominator. And this would give us 10 square root of 2 over 2. A square root times a square root loses the square root, or 2 times 2 is 4, but what's the square root of 4? 2. Either way you want to look at it, that's going to simplify to 2 on the bottom. Now, what else happens? This reduces with this, and we have 5 square root of 2. Okay, well if this side is 5 square root of 2, now we knew this one was 10 because it was given to me, then what is this side, because we're working with 1, 1 square root of 2? This side is the same as this side, right? So if we found 5 square root of 2, what's this side? 5 square root of 2. Okay, good job there. Let's do a couple more. Okay, so a little bit of practice with the 30, 60, 90 triangle. So now we're going to be using these relationships and these ratios to fill in the missing sides. Okay, so I'll pause it and draw those, and then when you're ready, we'll go ahead and get started. All right, now our goal is, if this is a 60, 30, so this is 60, so my relationship is a 1. Well, how do we get from 1 to 10? Multiply by 10. So if I'm consistent and multiply all the sides by 10, then we would have, what would this side be? 10 times the square root of 3, right? So it's just 10 square root of 3. What about on this side? 2 times 10 would be 20. Good. So we just figure out what did they do, and then we do it to all of our sides to be consistent. All right. So for here, if we have 5 square root of 3, and we look up here on this side, and square root of 3 was there, what did we do in this one? We simply multiplied this by what? 5. So then let's Let's do that consistently. So then, what is 1 times 5? 5, that would give us 5 on the bottom. And then what about here? 2 times 5 is 10. So you can see we would just determine what did they do to our special triangle, determine that, and then apply whatever that was to each of our sides until we fill in our missing sides. Okay, now to the heart of the reason why we even did that little mini lesson at all. We're going to work on this next triangle. Okay, so this was our special triangles that I gave to you the last time, and this is what we're going to work on. Now, our unit circle has a radius of 1, so this is why if this is side 1 and this is side 1, we want to know how these values change if the hypotenuse side must be 1. Now, we're going to do the same idea like we just did a minute ago. I'm going to locate the triangle, so that's going to be this one's my similar triangle. And I know side 1, so how do we get from here to here? We divide it by 2, right? So to go from 2 to 1, we divide it by 2. So we're going to consistently move ourselves around this and divide everything by 2. So 2 divided by 2 is the side 1. 1 divided by 2 would be the side 1/2. Good. We can just leave it as a fraction. Now, square root of 3 divided by 2, we're just going to leave it look like a fraction. Square root of 3 over 2. Okay, perfect. Now in a minute, these values on our unit circle, if you glance at your unit circle real quick, you'll see those values all around it. All right, let's work on the next one now. This one's the 45 degree, this one's the 45 degree, so I want to compare these two, and I'll say, what did they do to get to this to get 1? Divide by the square root of 2, right? Because the square root of 2 divided by the square root of 2 would give me 1. So consistently, let's go around this entire thing and divide everything by the square root of 2. So this would just be 1 divided by the square root of 2, because you have to put 1 in the denominator. 1 divided by the square root of 2. Okay. Now recall, if I wanted to simplify these, because a lot of times some unit circles you'll see those values. 1 over square root of 2, if we rationalize the denominator, okay, let's do some algebra. Square root of 2, square root of 2, that would be square root of 2 over 2. So that's approximately the square root of 2 over 2. These are equivalent. So some unit circles you will see this value, and some unit circles you will see this value. I think the one that we're going to be using has the one in blue, so